Hi, this is Joke Science. I'm David. Today we're going to go for a very simple topic in A-level chemistry. This topic is Avogadro's constant. Avogadro's constant is a very important topic that will help through many equations and topics that we'll be doing later on in further chemistry. So let's go straight through into it. So Avogadro's constant. We usually use Avogadro's constant to calculate the number of molecules and atoms in any given sample. 1 mole is equal to this constant, 6.02 times 10 to the power 23. It's usually a very longer number, 6.02 to something else, but we usually just, for A level, all you need to know is 6.02 times 10 to the power 23, and that's the constant. And this is the number of atoms. This is the number of atoms / molecules in 1 mole of a substance. There's also another constant you also need to know. You should have known this by GCSE, but in chemistry, obviously, you need to know it as well. 24, and this is the volume of gas that 1 mole can occupy at room temperature, and that's 24 decimeters cubed, or 24 centimeters cubed if you convert it. And I'll say it again, that's the volume of gas that 1 mole can occupy at room temperature. A couple of equations you need to know. Moles is equal to the mass of the substance that you're trying to calculate over the relative formula mass. You can also call that the MR. MR is the mass number in here. The relative atomic mass number, as you can see here. So if you don't know what they are, just know it's the large number. So it will be this bigger number. If we're trying to find the relative atomic mass of, relative formula mass of boron, or relative atomic mass, look at this bigger number here, which is 10.8. And you'll also find later on in chemistry the values of these relative atomic masses are more specific. In GCSEs might have been rounded up to 11, whereas in A level you'll find it's 10.8. Anyway, so now we've gone through the majority of the content which is very small for Avogadro constants 1. We'll probably be making another video about this, not sure yet. So it's the number of molecules. So for example, let's just do a couple example questions. Number of moles of atoms in 1 mole of H2O. H2O. 1 mole of water equals 2 atoms of hydrogen, with 1 atom of oxygen. So therefore, one molecule of H2O equals 3 atoms. Therefore, 1 mole of water molecules contain 3 moles of atoms. And let's go for another example here. CH4, which is also known as methane. 1 mole of methane equals 5 moles of atoms. This is useful just to understand the amount of moles, which when you know the amount of moles in an atom can tell you the amount of atoms overall which are in that substance. So yeah, that's just general knowledge. It's usually found when you're trying to calculate, when you're doing pharmaceuticals. Here we've got calcium hydroxide, Ca, and in brackets OH2, which means that the 2 is for both the oxygen and the both the hydroxide groups, or the oxygen and the hydrogen. So if we label out here, we got there's only 1 atom of calcium, 2 atoms of oxygen, as I said before. We usually call this number the subscript, and then 2 atoms of hydrogen. So calcium hydroxide has 1 mole of calcium hydroxide equals 5 moles of atoms. Now let's try something else. Now we think this is very relatively easy thing to understand, just counting the amount of atoms and calling out the number in 1 mole of that substance. So now we're gonna calculate the number of atoms in 1 mole of HCl. Now how are we gonna do that? It's very simple. Let's just take this example of hydrochloric acid right here. Now we know what we need to work out the number of atoms in 1 mole of hydrochloric acid. We need to come back to this one here. To understand the amount of, calculate the number of atoms in 1 mole of HCl, we need to use this formula here, back here, which was 6.022 times 10 to the power of 23. Sorry, I have to move my camera like that. Just put it over like back here. Well, I should just bring it back. So what we're gonna do is, so we know, first we need to know the number of moles in hydrochloric acid, which is 2 moles, 1 mole of hydrochloric acid is 2 moles of atoms. So that means you have to do 2 times by 6.02 times 10 to the power of 23, which equals 1.204 times 10 to the power of 24 atoms, and that's the amount of atoms in that substance, in 1 mole of that substance. Let's go for another example here. We have Na2O, which is equal to 3 moles of atoms. So we know that obviously because you have two sodiums and 1 oxygen. If you could find that, look at here. So we now know we have 3 moles of atoms. We just do the exact same thing, just with 3 times by 6.02. Sorry, just do 3 times by 6.02 times 10 to the power of 23, which is equal to 1.806 times 10 to the power of 24 atoms. That's it. I know this video is pretty bad, but hopefully it will give you some insight in understanding Avogadro's constant.